we're going to be finding missing angles in a right angle triangle. So provided that we are given two sides of a triangle, we can solve for the unknown angle. To do this, we have to use the inverse trig ratio. First off, let me give you a brief scenario of what I'm talking about. Now, suppose that we know the opposite side and we know the hypotenuse side. So remember what I'm saying earlier, that this equation actually has three pieces of information. If you know two sides, the opposite and hypotenuse, or actually any two sides, you can find the angle that you're interested in. So, but before we get into that, I am going to maybe present you with a scenario. So for example, if you get sine theta is equal to 1 over 2, where the opposite side is 1 and the hypotenuse is 2, and that you create the equation sine theta is equal to 0.5. Wouldn't it be nice if you could somehow magically undo the sine ratio so that you could isolate the angle theta? And in fact, that's what you can do. And it's a special operation called inverse sine. Now, talking from a algebraic point of view, it looks like this. We have an equation. If we do an operation to one side, we can ensure that we're maintaining equality if we do the same operation to the other side. So the operation I'm talking about is the inverse trig. And since I'm dealing with sine, it's going to be inverse sine. So what happens on the left-hand side? Well, inverse sine undoes sine. So all I'm left with is theta. But on the right-hand side, I still have this inverse sine, 0.5. So right now, I would like you to look at your calculator, look at your sine button. And just above your sine button, written in a different color, is sine to the -1. This is known as inverse sine. Same goes with cosine and tangent. They all have inverses. So allow me to begin. Example. Find each angle of measure, rounded off to the nearest whole number. If I know that the tangent ratio is 1.782, that is, tangent is opposite over adjacent. So if opposite over adjacent is 1.75 or 1.782, what is theta? Well, tan theta is equal to 1.782. What I can do to both sides is inverse tan. And I'm going to apply that to both sides. And on the left-hand side, all I'm left with theta. And on the right-hand side, I have inverse tangent is equal to 1.782. So in my calculator, I hit inverse tan, 1.782. And what I get is that theta is equal to 60 degrees. Oh, no, that's incorrect. 60.700 degrees. But since I'm rounding it to the nearest whole number, it would be 61 degrees. Okay, so I'm just going to erase all of this madness, and maybe I'm just going to take a look at sine. How about when it was sine theta is equal to 0.471? Now, a lot of you probably have developed these skills from previous years. And a lot of you might say, well, you would just move sine over to the opposite side. Well, that is the trick. But really what you'd be doing is you'd be applying the inverse tan ratio or inverse sine ratio to both sides. So here, theta would be And what I get is 28.099 degrees. Rounded to the nearest degree would be 28 degrees. I hope this helps. Now, we're going to solve for an unknown angle theta. These are the steps. I don't really care about the steps. I actually believe that you can do this by yourself. So to solve for theta, or to solve for any angle, you have to call one theta. If this is theta, this side is going to be the adjacent. This is the opposite. Well, now, what trigonometric ratio has adjacent and opposite? Well, that would be the tangent. So I'm just going to simply write tangent. Tangent is equal to opposite over the adjacent. I get to plug in my values. I don't know theta. That's the whole goal here. So tangent theta is equal to 14 over 5. So right now, I have tangent theta is equal to 14 over 5. You can express this as a decimal, and I think it would be 2.8. But instead, I'm just going to leave it as a fraction. So I'm going to apply the inverse tangent ratio to both sides, and I get theta is equal to 70.346 degrees. Some of you may want to, or may have questions. How did I get from this step to this step? And really, if I had tangent theta is equal to 14 over 5, I just employed inverse tangent on both sides. On the left-hand side, inverse tan cancels out with tangent, so I'm just left with theta. Let's move on. Whoa, this one's crazy. Now, this one doesn't interest me too much. This one does. Why does this one interest me and the other one doesn't? Well, I'm just going to say this one is more interesting to me because we haven't done the sine ratio yet. And I believe this is the sine. So if this is theta, I'm going to call my hypotenuse my hypotenuse. This side is the opposite. So if I'm dealing with opposite and hypotenuse, I'm just going to call this sine theta is equal to opposite over my hypotenuse. If I'm trying to figure out theta, I need to find my sine ratio first. So sine theta is equal to 8 over 9. I'm going to keep that as a fraction because, believe it or not, I like to do less work with my calculator, more with my pencil and brain. I get it wrong less. And then I'm going to apply the inverse sine to both sides. On the left-hand side, inverse sine undoes sine. On the right-hand side, inverse sine of 8 over 9. And what I get is theta is equal to 62.734 degrees. That's what pops out in my calculator. So I don't know if you know this, but this is 63 degrees about, right? Now this angle here, since all of them have to add up to 180, and this is 63 degrees, I'm going to suggest that this is 27 degrees. Did you know that a larger angle will have a larger side directly across from it? And that's what sort of seems to make sense here in the context of this question. All right. Let's move on. Now, if you notice, I'm doing these questions sincerely. I'm not jumping to an immediate trigonometric ratio. I label my triangles first. And the reason why I label my triangles first is simply I don't want to make a simple mistake and get it all wrong. So I label it as opposite and adjacent, and with respect to theta. The hypotenuse, which is this side here, is not included in the question whatsoever. So I have theta, I have to figure out the trigonometric ratio that has opposite and adjacent, and that is the tangent ratio. Now I'm trying to figure out theta, but in order to figure out theta, I need to figure out the tangent ratio first. And the opposite is 12.9, and the adjacent is 13. So if I'm trying to find theta, what I can do is I can apply the inverse tan to both sides. The inverse tan of the left-hand side cancels out tangent, but it remains on the right-hand side. And the answer that I get is theta is equal to 44.779